you took anything home, this would be the quote. Orgel's second rule: evolution is cleverer than you are. And it's a lesson that I learn daily. So just to let you know who Les Orgel was, he was a chemist, a British chemist at the Salk Institute in California. And he's the guy that figured out the origin of life. So if he says, if his second rule says evolution is smart, I believe him. Okay, so just to give you a little sense for where we're headed over the next 40 plus minutes, I'll tell you just a small touch about where you are for those of you who haven't been here. And then the rest of the talk is really about why we do what we do here. And then we'll get into, in the afternoon, we'll get into more specific practices. Here, Polly told you a little. We actually started thinking about growing grapes in 2007. We have 17 planted acres. 15 and a half of those are productive. We produce 31,000 bottles, 31,000 vines, 33,000 bottles in a good year, more or less. We're in an area called the Western Shore Uplands. I really sort of like that. Uplands means that it's not flooding. And we have marine sediment soils. Think about that for a minute. The last time carbon dioxide levels in the atmosphere were what they are now, we were 300 feet below sea level where we sit. And these are ultrasols. And Kelly was talking a lot about this because of all the microbial, because of the humidity, there's a lot of microbial action in the soil. It's why it's harder for us to build organic matter here. And there's a lot of breakdown. Ultrasols are characterized by really rapid weathering. And so in their ultimate form, they're known as the red clays of the South. It's a subtropical climate. Anybody from here understands that. And we have enormous change effects of climate change now. Heavy downpours, I'll show you something about that in a minute. We're starting to worry about heat, including when it gets over about 95 degrees, we lose photosynthesis. Last summer, actually, we are still technically in a federally declared a drought, a disaster area. We never had frost. We're close enough to Chesapeake Bay that we never had frost until 2020. Now we have it annually. In 2020, we had those of you who are growers will remember the Mother's Day frost. We lost 75% of our white production that year. Phenological dysynchrony, that's something that I got interested in, started paying attention to. And the example of that is for a couple of years, we didn't get enough chill hours. And so it took more heat for the vines to have bud break. And when that happens, other things that are more or less sensitive to heat or to temperature will have their emergence at separate times. What happened was we had bud break at normally we're 75 degree days. We had bud break 125 degree days, but the Japanese beetles had not awakened yet because there was no food for them. There were no dandelions yet. And so we had an epidemic of Aranos mites, which doesn't cause a lot of problem, but it does affect things. I put wildfire on here because we are under a smoke alert as we speak. And Polly told you about our future. On Friday, talk about downpours. On Friday at 8:30, right here, we had more than 4 inches of rain per hour over the next hour. And so we ended up in a little more than an hour, 4.8 inches. That was crazy. That's happened before. A lot of our efforts are designed to adapt to the changes that we're seeing. A lot of them are designed to mitigate that. And I sort of like this framework. It's called the Planetary Boundaries Framework from the Stockholm Resilience Center. Many of you will have heard of Johan Rockström. There are 9 ecosystem regulatory things that happen in Earth systems, and we have exceeded the safe operating zone in 6 of them, and some of them affect directly what we do. Interestingly, climate change is not the one that threatens us the most. Loss of biodiversity is the one that threatens us the most, except maybe what they're now calling novel entities, which is chemical and plastic pollution. Eutrophication, we all think about saving the Chesapeake Bay, but actually nitrogen and phosphorus pollution worldwide is also more threatening to the habitability of the planet. And so we can affect all of those by the way we work. And so, as Kelly said, know where you want to go, and we take these factors into consideration. And it's also a nice framework because it's sort of gives you a framework on which to hang your hat. So when I try to accumulate information, I like to categorize things, say, okay, that goes in that box. And it's helpful to think about that. Our objectives as a business are here, and I won't read through them, but leading the list is to restore the ecosystem. We like to say we farm for nature. We don't necessarily farm for grapes. Of course, we want to produce good crop. We want to produce good food and wine, but we farm primarily for nature. And we figure if we get that right, that the rest will take care of itself. So somewhat down on the list, sorry, Regina, if you're in the room, produce good food and wine. And we also think about our employees and our community. So it's important to us to create the sort of environment that our community wants to be in. And so as a business philosophy, Paul Hawkins sort of summed it up. The promise of our business is to increase or improve the well-being of humankind. That's what we're about. If we do it well, everything else will be fine. There's a lot of controversy right now. What is regenerative agriculture? I don't want you to worry about that. Just don't worry about it. There are several ways to think about it. California just defined it, for example. And a lot of places are trying to define it. And it's just everywhere. And they're all over the place. Maryland just defined it in law. I don't understand it. I didn't get it. There's another way to look at this, to try to define it by, or particularly the certification agencies are saying, if you do this set of practices where you have this set of outcomes, then you're regenerative. A few years ago, there was a paper where they lined up all of the things that people talk about, all of the practices that people do, or all of the outcomes that we talk about. And you know what? Only 2, and improving soil health and sequestering carbon, only 2 of those practices went over 50% of the respondents. So in this case, practitioner websites. So we're looking at, I know it's hard to see, journal articles and practitioner websites. Only 2 of all those practices. So there's no real agreement about what it is. The other way to think about it, and one of the controversial points, particularly in the California debate, is whether you have to be organic and or biodynamic in order to be regenerative. And so this, Jessica Vallot is the only survey I've seen like this. Jessica Vallot did a master's at the Harvard Extension School. She surveyed 20 vineyards in Switzerland, and she had a list of 9, a compendium, sort of those previous practices. She said, if you do this, you get a point. And how many practices do you do? And what you'll see here, which I think is really interesting, is all those who did more than half of the 9 you were just as likely to be conventional as you were organic or biodynamic. Kudos to every one of those. especially the one that did the most, who was conventional. So they're doing the work. I don't really worry about what it is, but we do have a working definition, and it's right here. Regenerative agriculture is an approach. It's not a process. It's not a practice. It's an approach. It's a way we think. Kelly, thank you for emphasizing thinking. That relies on natural processes, nature, to promote diverse life and vitality in agroecosystems. If you're working towards that, monitoring towards that, you get credit from me. The last section is I want to rely on my background as a physician, and Mark will recognize some of this. And I'm going to just start with something from Wisconsin. It's called the County Health Rankings System. And they've done empirical work to understand what about the system at the county level makes you healthy. What makes a healthy population? And medical care is only 20% of the effect. The rest of it is all context. And so I like to draw on this analogy because, and the context, by the way, housing, diet's really important, and so forth. But there's a direct analogy with what we do in viticulture. And so, for example, allopathics. Now, I'm an allopathic physician. Mark's an allopathic physician. We trained to diagnose and treat disease. We didn't train to think about health of populations. We didn't train to think about health. How do we produce a healthy vine? And so and there's direct analogies with that in viticulture. So diagnosing plant disease. How much time do we spend? How much time do we spend thinking about what's this disease and what do we do about it? And then we have other things like there's a direct analogy with pruning and surgery. How do we get those right? Vaccinations. I'll talk more this afternoon about what disease suppressive soils are, but that's also an analogy. But we don't really talk about, we talk some about appropriate training systems, but we don't really talk about holistic factors like how do we get the vines a healthy environment? How do we feed them well? We talk about minerals, but we don't talk about the other things that are important. So a lot of what we'll talk about the rest of the day is on those. I want to think about ecosystems a little bit. This will put a little more specificity into what Kelly talked about. What is an ecosystem? There are small little ecosystems. There's the vine ecosystem. There's the fruit zone ecosystem. There's the larger ecosystem. Those are all relevant. It is a community of organisms that are functioning together. They tend to have certain characteristics. For example, they conserve energy and mass. So they take in energy from the sun and they expend energy, and it tends to be constant when they're in equilibrium. They are interdependent and they're self-regulating. So they will draw themselves back. They will be resilient to disturbance, like that 5 inches of rain we had on Friday night. So I don't know, I didn't go in the vineyard on Saturday, but I know where the mud puddles usually are, and there were none. So the water had infiltrated even that quickly. And they provide a whole bunch of, the scientists call them ecosystem services. I've called them holistic services, but it's what cleans our air and our water, important for us, what produces food or pollination, what produces food for the animals, the grasses, for example. They do pollination, nutrient cycling. We'll talk a lot more about that. But one of the hallmarks of a healthy vineyard ecosystem is a lot of nutrient turnover, so that the vines, when they ask the microbes for their for what they need, they will get it back because they can produce it. Reduces pests. I'll show you data on that, and they decompose waste and pollutants, including pesticides. And so having having lots of microbes in the soil is going to help you there. I'm thinking at a high level, how does this work here? We have 31,000 grapevines. If we had nothing else in the system, what's going to be there? Things that like to eat grapevines. That's going to be what's attracted here. By creating the biodiversity in our system, and remember, I already referred to this. We had lost all of our soil biodiversity. I knew this. What I hadn't really thought about until 10 years ago or so, actually, this is when Ron helped us because he identified the mite infestation that we had when we had when we'd sprayed too many times for Japanese beetles. And that sort of started the whole thing. Joe was here at the time. You might remember this. What are we going to do about the mites? No, we're not going to do a miticide. We're going to change the environment. And so by creating the diverse environment now, we have the natural predators and parasites of the pests. And so we've reduced that pest pressure. And a lot of that is maintaining those natural predators when the pest isn't there. So they have to have other things to eat. So you have to have more plants, mostly plant species. Everybody knows spotted lanternfly. I know they're starting to talk about it in California, so it should be everywhere in the country now. We have it here now, too. This is from last summer right down there, and we'll go down and talk about it. If we have diverse landscapes, and I love yellow and black garden spiders, and boy, when they do that, when they catch one, boy, they do that fast. It's really something to watch. And so they're helping us. And so we've relied on a lot of these processes. We'll talk some more about that when we walk around. Incidentally, anybody else have yellow and black garden spiders in their vineyards? They like to make their webs between the rows. And it's always in September. And so when you're walking down and you're looking at the fruit, you're really just focused in on what's going on with the fruit. All of a sudden, it's right in your face, all across. They do make a beautiful web, though. They're very distinctive. There are various tools that we have, and these are just the ones that we use here to be able to modify that landscape, to be able to modify the environment that creates healthy vines and modify the ecosystem. And so we'll spend some time talking about cover crops. We'll talk about a lot of these practices this afternoon. Kelly talked about livestock. And then we don't want to forget the landscape. It's not just about the vineyard. It's about all of the surroundings. So we consider the hedgerows and the woods and the riparian areas, like down over here, things that are important to managing our ecosystem. And as Kelly mentioned, we don't want to forget the social ecosystem. What makes a healthy vine to us? It's one that that's actively photosynthesizing. It's doing its part. It's achieving its role in the ecosystem. I mean, we don't have vinifera native to this area, but there are lots of grapevines, and they're providing a role. And so the sunshine starts everything. This is the energy flows that Kelly talked about, and launches the plant metabolism. The minerals are combining with the sugars to make proteins, and healthy proteins make healthy vines. Those are the things that make flavor too. And then there are a whole bunch of secondary plant metabolites. We call them phenolics. We really like those in wine. We call them vitamin C, which is the precursor for tartaric acid, which makes our wines fresh. So these are all important part of the plant metabolism. And if they're not functioning, the vine won't be fully active. It won't be healthy. It won't be robust. It won't be resilient to disturbance. Photosynthesis, you all know about that. You think about it in this simplified way, using solar power to remove carbon dioxide from the atmosphere. I really, this is Les Orgel's second rule in action. Nobody would have thought about this system. It produces carbohydrates and really cool byproducts like grapes and oxygen. But it's actually a really complicated process involving 11 enzymes. And there is currently, with funding from the Gates Foundation, an attempt to modify this so that you can convert the type of photosynthesis called C3 grasses that are the short stuff that we do, modify them to do 11, to do more efficient photosynthesis called for C4 grasses like corn and sorghum, which are very effective. There are 11 enzymes in this system. They've been at it for 25 years. They've done one. I'm glad they're working on it, but I'm not counting on it. Anyway, the minerals that we provide and having balanced nutrition is really important for this process. And they function as to activate enzymes, to be cofactors for enzymes, and just in nucleic acid synthesis and protein synthesis. So really important functional. There'll be a quiz on this chart. Photosynthesis is driven in the plant, but it depends on the rhizosphere. The rhizosphere is the interaction of the vine root with the microbes. And we'll spend some time talking about arbuscular mycorrhizal fungi in a moment. But when the plants go about their photosynthetic activity, they produce sugars, and up to 2/3 of those sugars are now excreted through the roots as photosynthates to feed the microbes. And then they go about their various functions. There is, of course, it's also feeding disease organisms. We want to recognize that. But there are a whole bunch of other activities that are useful. In return, particularly if we have a fungal-dominated system, we're getting a whole lot of complex molecules fed back to the vine. And so that's very helpful. We're also, in a fungal-dominated system, we're getting a more acidic environment, which results in less conversion of ammonia to nitrates. So when Joe tells us don't add nitrates as a system, this is the natural way. So one of the concerns that I had when we started was by producing all this soil organic matter, and we've gone from 0.3% on average across the vineyard, depending on what part of the vineyard we measure, we're now up to 3.8%. That now there's a lot of nutrients. And one of the reasons that this is not producing overly vigorous vines is because we're now more fungal dominance. And so we're less likely to make that conversion from a non-plant available form to a plant available form. Having effective protein synthesis is really crucial to the plant for a number of reasons. And of course, having the right level of nitrogen uptake is important to that. But incomplete protein synthesis, if you have a bunch of free amino acids wandering around in the system, that actually calls insects. They like that better. Insects cannot digest many complete proteins. They need to have them broken down by something else. And so if the plant has complete proteins, they're less likely to have herbivore damage. And of course, this is important to us. This is a glassy wing sharpshooter. We don't have those here. We have broad-headed sharpshooters, but they are also the vector for Pierce's disease. Active photosynthesis also produces a number of immune functions. Is how the plant, and we're just really starting to understand this, but it's how the plant responds to either injury or to an infection, botrytis or downy mildew or that kind of thing. And so, and it does this in a number of ways. Epigenetic regulation, for example, is when a protein lands on the genes and it turns them on. So when a insect bites the leaf, there's a change in the genetic function that will recruit signaling molecules that will be sent almost immediately down into the rhizosphere, and that will allow the vine to tell the fungi, basically signal using chemical signaling, that it needs something to help repair. There are other ways of doing this with non-coding RNAs and stuff. We won't talk about that, but notice here, two of the most important signaling molecules or repair molecules, polyphenolic compounds. Talk about wine quality. I think Adam was asking about what happens with wine quality. We want more polyphenolics, and that's where they come from. Terpenoids, the same thing. And we'll talk a lot more about microbial interactions. I like to focus on vitamin C here, sort of a repetitive theme here, because we can measure this. And so when an insect bites our Sauvignon, it will send a signal down. It will send some sugars down. They feed those microbes. The microbes produce vitamin C, send them up to the leaf. Vitamin C is tart. The insects don't like it. They'll bite the leaf again, and they'll say, I don't really like that. I'm gonna go down and eat some clover on the floor. So that's very helpful. Vitamin C is also a antioxidant, and so the plant uses it the same way we use it for injury repair. So really important to have this sort of chemistry behind us. I love this because it makes me practice big words from when I was a cellular immunologist. Hologenomes. This is the notion that it's not just the plant that we're worried about. It's actually the combination of the plant and its environment. And so in this case, the plant and the fungus that it's interacting with. And those don't change independently all the time. They actually have co-evolved over 400 million years. So they know how to work together. This is a long-standing mutual relationship. And that entity, that combination, is known as a holobiont. And there are a whole bunch of things that we can do to modify that so that in our agroecosystems, so that we can get the outcome that we are looking for, because we're part of this system. For example, one of the influences, of course, it differs across all parts of the vine. It differs according to the soil that you have. So Kelly's holobiont is going to be different from ours. We can modify it by our choices of both scionwood and rootstock. We can modify it by our vineyard practices. And we'll talk, and a lot of what we're going to talk about is around this box, but also it varies according to the climate and the diversity within the vineyard and how you've set it up, both between the vines and between the vines and the plants in the surrounding environment. Those are all evolving together. Okay, I just want to talk about the outcomes for a minute, how the system has been working. And I have to be honest, there is a transition period. If any of you know James Rebanks, wrote Pastoral Song, it's really worth reading just for the prose. It's a beautiful book. Rebanks is a shepherd in Scotland. And in his book, and I was listening to it while I was hedging one day, and he says, farming as we do is economic suicide. Oh, God. That was terrible. But there is a transition cost. And one of the things I think we'll talk about is that we have to be prepared for them. It's good that others have gone before us so we can avoid most of them. For example, when we started farming in this way, we were encouraging, remember I said that the pathogens are also there. We started encouraging pathogens too, particularly Brettanomyces, and boy did we have trouble trying to deal with Brettanomyces. As the system gets more mature, the Brettanomyces reduces. because it's being crowded out by other microbes. But it was tricky. There's another reason. It's a policy reason. We actually incentivize the bad agriculture at a policy level. And so we have this really wonderful system to do carbon capture. In fact, in some audiences, I introduce myself as I'm in the carbon capture and storage business. Because it's true. Here, we are on average net sequestering about 250 tons of carbon dioxide in our soil every year across the vineyard. It's a very straightforward calculation, just based on soil organic matter. Incidentally, that's the equivalent of the emissions from burning 30,000 gallons of gasoline. Microsoft, so there are now machines, shiny machines, that will do the same thing. They basically take a tray of limestone and they blow air across it, and the limestone absorbs the carbon dioxide, and then after a while they have to go out and they have to burn that carbonate in order to free up the carbon dioxide, and then they store the carbon dioxide down in an old mine or something. Microsoft pays somewhere between $800 and $1,000 per ton. Wouldn't we like to have that $1,000 per day, $250,000 in income? Instead, what our elected officials have chosen is to increase our property taxes on this farm. So it doesn't make much sense. We have to work at it. We have healthier soils, and we'll talk much more about why that is, but just some measures. We can measure soil organic matter. I already told you how we're doing that. It's now more than tenfold. I talked about the water infiltration from the 5-inch rain bomb that we had on Friday. It now works. In 2018, when we really went all in on this, we would have standing water in the vineyard, lost vines to puddles, and it would be there for weeks. We couldn't drive a tractor. We couldn't get into the vineyard. Now we can. And we get better nutrient turnover, and that activity is really important. We've reduced our chemical and physical footprint. And this is the explicit goal, if you remember from the slide. We want to increase our biological activity, but reduce our chemical and physical footprint. On average, over the past decade, we've reduced our tractor passes by 17. Some of those are mowing. 6 of them, about 5 or 6 of them, are for pesticide applications. And so we've reduced our fungicide use by about applications, counting number of applications, by 30%. And we've really reduced our insecticide applications. Last year we did 1, right, for beetles. We had actually gotten down to 0. And then during the pandemic, we started mowing larger areas outside. And so now we have turf grass, which is the native for beetle larvae, for grubs. And so now we have turf grass. Now the beetle pressure actually comes from inside the vineyard rather than outside the vineyard. It's really annoying. But it is that constant adaptation and monitoring. And we're producing more and better wine. Of course, this is going to vary according to the season, but on average, over the baseline, we're producing about 30% higher yield. We've had a 50% increase in the titratable acidity, which the winemakers know is tartaric acid, a metabolite of vitamin C. So that's coming from that healthy soil. And actually last year, for the first time, we had a 75% increase in yan. So now we're getting much more natural nitrogen into the vines, which is helping us with our fermentations. For those of you who don't know, yan, yeast assimilable nitrogen, it's a measure of the nutrient availability in the grapes when they go into the fermenter. There's a certain level where we know if we don't have it, the fermentation is going to stall out. And And so we have to add it. So now what we're seeing, we on average, we're about 50 across the vineyard, which is about a third of what you want. The goal is 100, 150. That's up to 100 now. So, right, Curtis? 80 to 100, something like that. Anyway, so more and better wine. So it does have practical advantages. I said we like the social environment, right?